Measure of central tendency. Our focus in measure of central tendency is on mean, median, and mode. Depending on the distribution of the data, we're going to focus on one of these measure of centers to represent the center of the data or the typical value. So we're looking for the balancing point. If you change the distribution, the position of your balancing point will change as well. As you remember, visual summaries of data are great tools to get some information and insight. But eventually, we have to do a little bit of data analysis and do calculations to interpret the numerical summary for our data. Specifically, when it comes to numerical data, we're interested in doing some calculations. For the measure of central tendency, the very first topic is the mean of the data. To find the mean of the data, you're going to use the observations. If you have population, well, the mean is denoted by mu. And if you have sample, the mean is denoted by X bar. So for each one of these, they have a different representation. Mu, which is the summation of all observations divided by the number of values in your collection. And then for your sample mean, it's denoted by X bar. Again, you have the summation of all observations divided by the number of values in your collection. As we mentioned before, if you have some observations and you have some frequencies, the position of your balancing point might change as well. For a sample mean, X bar of observations, X sub 1, X sub 2, X sub n, X bar is equal to X1 plus X2 plus the rest of the data, and you're going to stop at Xn divided by n, or the summation of X sub i's. I start from 1, goes to n, divided by n. For simplicity, you can just write it as sum of xi's. And again, since it's a sample mean, we denote this by X bar. For example, the prices in dollars for a sample of products before the launch of pricing strategy study are listed below. What is the mean of the data? First of all, you have a sample mean. So it is equal to X bar. First, add all of these numbers together. The summation is equal to 1,810. You have 7 data in your collection. So the sample mean is $258.6. The mean price of the sample is about $258.6. Caustic stress corrosion cracking of iron and steel has been studied because of failures around rivets in steel boilers and failures of steam rotors. Consider the accompanying observation on X, which is crack length. So these are our observations that we're going to focus on. X sub 1 is 16.1. X sub 2 is 9.6. And as you can see, you have observations down here. What is the average? What is the mean? What's the typical value? What's the typical crack length? If you add all of these numbers together, it is going to be 444.8. So the sample mean is equal to the summation divided by, you have 21 observations. So when you list this like this with observations, you can actually see what is the number of values in your collection. 21. And if you do the division, you get 21.18. So a physical interpretation of X bar shows that how it measures the location or center of your sample. If you think about graphing this, remember that you can use a dot plot. For a dot plot, basically take each one of these observations and use a dot representing this data. And please take a look. This point here looks like an outlier. And the majority of the data are located on the left-hand side. And as you can see, the center or balancing point is located just right here. The next measure of center is the median of the data. The median of the data is the middle value after you order the data from smallest to largest or from largest to smallest. For example, suppose you have this data and you're going to order these. The middle number is equal to 4, and it is the median of the data. Now, if you order the data and you have two values in the middle, you're going to find the average of these two values, and this number 5 is going to be the median of the data. More formally, the sample median is denoted by x tilde. So you have a tilde on top of your x. Please make sure to order the data. The single middle value if n is odd. So if you have odd number of values in your collection after ordering the data, n plus 1 divided by 2 ordered value is going to be your median. However, if you have even numbers of values in your collection, the average of n divided by 2 and n divided by 2 plus 1 ordered values is going to be your median. The risk of developing iron deficiency is especially high during pregnancy. The problem with detecting such deficiency is that some methods for finding the iron status can be affected by the state of pregnancy itself. Consider the following ordered observation on transferrin receptor concentration for a sample of women with laboratory evidence of overt iron deficiency anemia. So these are the data that you have: 7.6, 8.3, and so on. There are 12 data in your collection, which is even. N divided by 2, which is going to be just 6. And seventh order values must be average. All right. So the median is going to be 9.7 plus 10.4 divided by 2, which is 10.05. Just a quick observation for you. So 20.4 is the largest value. If this wasn't in the sample data, then the resulting sample median for n equals to 11 observation would be the single value of 9.7. So compare 9.7 and then 10.05. So the median is 9.7 if the maximum value wasn't present here. And then if you calculate the mean of the data, the mean is going to be 11.61, which is a little bit larger than the median. So the outliers here, which are three values, 15.2, 16.2, and 20.4, has an impact on the measure of center. When you're talking about the mean, median, you can do the calculations before and after eliminating these outliers to understand the behavior of the data causing by outliers as well. So when you have skewed data using outliers with skewed data, the median is more reliable than the mean. The median is the best representative when it comes to skewed data set, either skewed to the left or skewed to the right side. Visually speaking, if you have a normal data set, the mean, median, and mode, they are all located in the middle of the data. And all of these data, since they are the same, are going to be best representative for the measure of center. If the data is skewed to the right side, you have the tail on the right-hand side. So you say that the data is skewed to the right. The mode is located on the left-hand side. Mean is on the right-hand side, and the median is located in the middle. The same if you have a left tail test, left tail graph, which in this case, you have the tail on the left-hand side. So since the tail is on the left-hand side, the outlier is on the left-hand side, you say that the data skewed to the left. And again, as you can see, the median is in the middle of the data, best representative for skewed data set.